Great seeing you here again. My name is Luc de Ceuster, founder of the Ceuster Academy, and welcome back to one of our new videos in the Math Survival Guide. In this video, I will look at a problem where we want to find the intersection of two lines. And in this example, we're considering that both lines, or the equations of both lines, are given in the point-slope expression of the form y is mx plus k. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the problem. We want to have an intersection between two lines given in their point-slope expression. And when we draw this in a x and y diagram, we find those two graphs, those two lines. The first line, y is m1x plus k1, which has clearly a positive slope. And the second line, y is m2x plus k2 with a negative slope. It is very important to understand that those two lines have an intersection point x1, y1, and we know that those two lines will intercept because they're having different slopes. So m1 is not equal to m2, and that's a condition for two lines to intersect. Or to intersect. So this is what we are going to try to find, and let's have a look at finding the intersection point when we have those two expressions. At the intersection point, we know that the values of both lines, y values, are the same as are the x values. But here we already have the expression y is mx plus k, so we already can write that in this point y1 is equal to m1 x1 plus k1 for the first expression, for the first equation, and for the second equation we have basically the same. y1 is equal to m2 x1 plus k2. And what happens here is that both lines are y1, the left-hand sides are equal, so the right-hand sides also have to be equal, which then results in the equation that m1 x1 plus k1 is equal to m2 x1 plus k2. And based on this, we can in fact find the intersection. So this is the equation we found. And what we do now is we bring all the parameters in x, all the x1 to the left-hand side, and we keep the k factor at the right-hand side. So we will be able to find an expression. x1 is a function of. What we do next is to take out x1, and we can rewrite m1 x1 minus m2 x1 as m1 minus m2 times x1 is equal to k2 minus k1. I forgot the index 1 there, but it has to be there. And then we find x is k2 minus k1 divided by m2 minus m1. So that's basically the value of x1 which we had to find. So that's the first parameter that we have. The next thing we can do is to put this parameter into one of the equations to find y1. We see that y1 is m1 times x1, and x1 is given by k2 minus k1 divided by m1 minus m2 plus k1 we find. And we see that we can now control if this is valid for the second equation. So we put in the second equation the values of x1 and y1 that we found before. So we can say, or we have to verify, is y1 equal to m2 x1 plus k2. And when this is correct, we can say that we did the calculations correctly, and we found the intersection point x1 and x2. Let's have a look at an exercise. We look at two lines here. The first line is y is 3x plus 1. We have a positive slope. And the second line is y is minus 2x plus 2, which is in fact a line with a negative slope. We now can see that x1 is equal to k2 minus k1 divided by m1 minus m2. We found that formula before, or we can do just the calculations if you want to. The best way for you to do it is the best way how you like it and what's the fastest for you. And we find that k2 minus k1 is 2 minus 1, and m1 minus n2 is 3 minus minus 2. So we find that x1 is in fact 1/5 or 0.2. Then we have y1. We have to replace x1 in the second in this equation to find y1. y1 is 3 times 1/5 plus 1. So we've chosen the first equation. We can also choose the other equation. That wouldn't be different, but it's better to stay with the first equation and then use the second equation for the controlling. So we find that this is 3 plus 5 divided by 5, and we find that y1 is 8 divided by 5, which means that the intersection point is 1/5 and 8/5. So we have the coordinates here, and the next thing to do is the control. So we bring those 2 points in the second equation. On the left-hand side we have y, which is 8 divided by 5, and is this equal to minus 2 times x, 1/5, plus 2. And when we do the calculation, we see that at the right-hand side we also find 8/5, which is basically the proof that we have found the correct intersection point because it's on both lines. So that's it for this video. We found the intersection of two straight lines using the point slope expression. It's very quick. And in the following videos, we will have some alternatives. We will be looking at the standard equation of the straight line and then a combination of the standard equation and the point slope expression. But that's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.